Let us now look at the 7-layer OSI protocol, following which we'll also look at the TCP and UDP network protocols. So what is the OSI model? Now, the OSI model is a theoretical model, and it's a way of subdividing a communication system into smaller parts called layers. The OSI term here stands for Open Systems Interconnection, and it's a product of the Open Systems Interconnection effort at the International Organization for Standardization, that's ISO. And it's a set of internationally recognized non-proprietary standards for networking and for operating system involved in networking functions. So the layer here is a collection of conceptually similar functions that provide services to the layer above and receive services from the layer below it. So these are the 7 layers. Here you have the application layer on the top, and then the presentation layer, session layer, transport layer, network, and then from the bottom there's physical and data link. So the job of the physical layer is to transmit bits over a medium to provide mechanical and electrical specifications. And the job of the data link layer is to organize bits into frames to provide hop-to-hop delivery. The job of the network layer is to move packets from the source to destination to provide internetworking. And the job of the transport layer is to provide reliable process-to-process message delivery and error recovery. And the session layer is to establish, manage, and terminate sessions. And the presentation layer to translate, encrypt, and compress data. And for the application layer to allow access to network resources. So now think of it this way. So let's say that you have various devices. So let's say this is one computer, and let's say this is another computer, or let's say I have an iPad over here. So I'll think of it as a separate device on a network or a node. So each of these devices would have these 7 layers implemented ideally. Like, this is a theoretical layer, so it doesn't exist in practice. There are other protocols which are there, but you can imagine it this way, that this one has these 7 layers and this one has these 7 layers as well, and all the nodes on a computer and on a network, they also have these 7 layers implemented. So the physical layer here means that it's a physical connection which is connecting all of these devices, and then that's transmitting the bits over the medium, and it provides mechanical and electrical specifications. And so the way it moves is that all the services from the application layer to the physical layer on this move from the top to the bottom over here. On the physical layer they move down, and then when it reaches the next node over here, then again it moves from here to the top of it on this particular device. So all the layers, the 7 layers across the network, you can think of them as corresponding to each other. The physical to the physical, the data link to the data link, the network to the network, the transport to the transport, and so on. So these are the 7 layers here. The application layer is the one on the top, and it provides the services to the user. And then there is the presentation layer, whose job is translation, compression, and encryption. For session layer is for dialogue control and synchronization. Transport layer is basically taking a message, a large message, and then breaking it up. So when you have, let's say, any message on a piece of paper which is written, and this could be a document that you're sending over the network, and this is basically broken up into various packets at each layer. So the transport layer is basically concerned about the end-to-end delivery of this message. So even if it is broken up into various packets, these packets are ensured that these packets go from the one computer to the next, and in case any messages are lost, those are resent depending on the kind of transport layer that is implemented. So the network layer is again concerned with the delivery of packets from the source to the destination. And the data link layer is concerned with the hop-to-hop delivery of frames. Now, across a large network, there are various hops. It doesn't really go directly from one computer to the next, because one computer can be in one country or in another country, or in large geographical distances. So there are lots of devices along the way which help. There are routers which help route your packets from one node to the next. So the data link layer is just concerned about the transmission of packet from one hop to the next. And then you have your physical layer, which moves the actual bits, zeros and ones, from one hop to the next. So one easy way to remember these 7 layers is by using this phrase or sentence: all people seem to need data processing. So all is for application, P is for presentation, S is for session, T is for transport, N is for network, D is for data link, and P is for physical. So the responsibility of the physical layer is the transmission of raw bits over a communication channel. And the issues here could be the mechanical and electrical interfaces, the times per bit, and how much distance is required for transmission from one computer to the next. And it is concerned with transmitting raw bits over a communication channel through hubs, wires, modems, network cards, basically anything that is physical to the network. And this is the bottom layer in the network, and it converts the bits into electrical signals for outgoing messages, and converts the electronic signals into bits for incoming messages as well, and manages the interface between the computer and the network medium through coaxial cables, twisted pair, etc., and tells the computer driver software what needs to be sent across the medium. So these are things that you typically associate with the physical layer. Here there's the cross cable, the network cable, and then the network interface card, and so on. And then you have your the second layer on top, which is the data link layer. And the responsibility of this layer is to provide an error-free communication link. And the issue here is framing, which is dividing data into big chunks. So when you have this data, which can be like, say, one document to lots of documents, and dividing it into chunks, that's the job of the data link layer. And then it attaches bits at the beginning, which are called header bits, and attaches bits at the end, which are called trailer bits. And it also is concerned about adding the addresses for where the packet needs to go. So the data link layer takes raw transmission and transforms it into a line that appears free of transmission errors in the network layer. And you'll also find smart devices such as switches in the data link layer. The digital information that needs to be sent, such as email attachments, etc., these need to be broken down into the smaller bits known as packets. And these packets require some information similar to sending a letter in the mail. So here you have hubs, routers, and switches, and all of these are typically associated with the data link layer. And this layer is also the one where you find the MAC address of the computer, which is also known as the media access control address. So on Windows, you would go to your terminal and you would type ipconfig or ipconfig space /all. And on a Mac, you can type ifconfig. And here you can see, you'll be able to see various things when you type ifconfig. And what you can look for is the MAC address, which is typically in this format, which is a physical address over here with 1, 2, 3, 4, 5, 6. Here you have these hexadecimal codes over here. So the MAC address is a unique identifier assigned to network interfaces for communications on the physical network segment. And they are also used over Wi-Fi. Okay. And you can also try the trace route. So yeah, so this in this case, what you're doing is that you are tracing the route to go to yahoo.com from this particular computer, and all the IP addresses and the hops in between are seen. Okay, and here it says 64 hop. So this is an example of a packet when information sent across the network is broken up into packet. Here the information can be a document or audio or a video file, whatever you send across the network or access from the internet. And it contains there's the bits of information over here, and then you have the header bits and the trailer bits. And in the header you have the MAC address if it is available, or the IP address or the network address of where it is going. We'll look at IP addresses in a while. And it also contains the MAC address from your computer and the IP address where it came from. And that's information which is typically associated with a packet sent over the network.